Hello. Yeah, in this video, I will show you how to perform a regularized discriminant analysis using R. And this is just one approach. We will use the RDA function in the R package klaR. All right. So first, you can check if your RStudio has the klaR function. If not, just install the package. Once you install it, you can load it up. And then you can actually do question mark RDA. It brings up the help information on the RDA function here. So it's called regularized discriminant analysis. It builds a classification rule using regularized group covariance matrices. We'll see what that means. That are supposed to be more robust against the multicollinearity in the data. So if your data highly correlated, just like in linear regression, they may distort estimates and lead to incorrect inferences. Okay. And if you have multicollinearity in the data, then you can consider doing a regularized discriminant analysis to reduce the impact of collinearity. Okay. And also the RDA works even when n less than p, which is saying the sample size smaller than the number of variables. For example, you may have microarray data in which you have 9,000 genes and you got 50 samples. Okay, and you want to build a classification rule, then you have to be careful because the covariance matrix estimated will be singular, so you cannot do it in the traditional way. Okay, and you can read all these help information about the arguments, details, and the values. I want to point you to this section with the formula for the linear convex combination of the covariance matrix. That's the regularized covariance matrix. There are two ways. The second one has two parameters, gamma and lambda. Okay. So, and for the gamma and the lambda, there are a couple of extreme cases. So gamma equal to 0, lambda equal to 0. This is the QDA. Gamma equal to 0, lambda equal to 1, and the RDA becomes LDA, linear discriminant analysis. Gamma equal to 1, L equal to lambda equal to 0. We get conditional independent variables. So this classification rule is very similar to a naive Bayes rule. And if you have gamma equal to 1, lambda equal to 1, then it's classification by using Euclidean distances. Okay, so there's a couple of extreme cases. Also, you know, by specifying gamma and lambda function, you can actually use the RDA function to do QDA and LDA. Okay. All right, let's take a look what RDA does in real action. Okay, let's create a data set, load in the mass library, the matrix library, set a random seed, 100 observations and 50 variables. We specify correlation matrix, make sure they have moderate correlations between the variables, and then and we ensure the matrix is positive definite because it's a covariance matrix. Okay, and then we generate the data, and then assign a group, and then put them into a data frame, and then here's the data set we created. Okay, so the purpose is to classify into group based on the 50 variables, okay, predictors. Okay. To use the RDA function is very simple. So RDA group tier the dot data equal to data frame. You run it, it's very quick. You can print it out. You can see It tells you the regularization parameters it used, gamma and lambda. Gamma is 0.2, lambda 0.55. And then prior probabilities of groups, A and B, there's 50-50%. And the accuracy or the misclassification rate for the apparent, that's just directly from this data set, is 0%. So we have perfect classification on this data set using RDA. But we know that's too good to be true. If we use cross-validation, then the cross-validated misclassification rate is 43%. Okay. So anyway, then we can do additional analysis for on the output of this RDA analysis. For example, we can do predictions, and then we can calculate the confusion matrix. See, you get perfect classification there. And you can plot the heat map of confusion matrix, load the library ggplot2 and reshape2, and then you can calculate confusion matrix, and this confusion matrix, put it into a data frame, then using the ggplot function, and then using this. You see this heat map, but since we have a perfect classification, and it's not very interesting, but so be it. Okay. And we can compare to LDA and QDA. So the traditional way to do a LDA is to use the LDA function in the mass library, doing like that. But in here, we can use the RDA, and we specify gamma equal to 0, lambda equal to 1, and then we calculate prediction, confusion matrix, and here's the confusion matrix from the LDA. So it is not perfect. Okay. And similarly, we can do QDA using the RDA function, but specifies gamma equal to 0, lambda equal to 0. Calculate prediction, construct a confusion matrix, and print it out. It's the same as the LDA matrix. Okay. But you can see the RDA does better than LDA and the QDA on this data set if we don't consider cross-validation. Okay. But if we want to perform cross-validation, then we can load the library caret, set random seed, and specify train control. We're using cross-validation method. It's a tenfold validation. We expand the grade, lambda from 0, 1, gamma from 0, 1, and it's like 5 by 5. Okay, that's the grade we're going to search on. And we use the train function to do the cross-validation. It's going to take a little while. And then we have the best lambda, best gamma, print it out. In this case, it's very extreme. Both gamma and lambda, their optimal value is 1. Okay. So, and you can redo this RDA by rerun the RDA function, but specify gamma equal to 1 and lambda equal to 1. Okay. All right. So this is a quick tutorial showing you how to do RDA using the R package klaR. Okay. And in another video, I will introduce another way to do RDA. There's actually R package called RDA. Okay. I'll see you in that video. Thank you.